Hi, my name is Mengzi. In this video, I would like to share about my recent research in the Taurus Assistant Agent Design, which is for the module Designing Intelligent Agent. In today's world, AI-driven intelligent agents have really dominated trending software and hardware applications, from GPS-based path planning systems that you can see in all these navigation softwares to vacuum cleaners in your house with integrated computer vision detection to really detect where it needs to clean. Unlike traditional agents that are designed to solve some rational problems, for example, clean the house, the intelligent agent that is designed for assisting the user stands a distinguishable position in really solving the real-world problem with much complex task requirements. The goal of providing personalized assistance is crucial, as this agent has to interact with the user and to assist in a personalized manner, which is beyond the capability of existing state-of-the-art agents like ChatGPT that act like a question-answering machine with a static interaction mode. So, what is this paper about? In this paper, we have three major contributions. First of all, recognizing the needs and also the challenge in evaluating open-ended tasks like assisting the user in planning a trip. This paper first derives optimization problems, focusing on evaluating task requirements and selecting the most effective strategy within cost constraint using cost-efficient matrices. We propose three matrices using shadow entropy, confidence, and also the assumption ratio as very effective measurement for determining whether a task is very good for the agent to solve. By using this kind of approach, our agent can evaluate the task without generating the actual response, which really saves time and also saves the API cost. Secondly, in order to solve the problem of existing assistant agent in not recognizing the need of interaction, we propose this so-called guided task transformation framework that enables AI agents to refine user interactions into detailed task requirements and also user profiles. So by doing this transformation process, the agent can know more about the user and also know more about the task in order to solve the problem more effectively. Lastly, through our experiments with synthetic traveler data, we implemented this Taurus assistant agent, and the strategies and also the data mining algorithms are compared to identify the best practices in simulating interaction processes. By doing this, our intelligent agent has industrial value. It can be applied in a real-world scenario. Let's now move on to the methodologies. Here, we propose three intuitive strategies for interaction and four data mining algorithms. First of all, we have checklists, which is essentially a list of questions to be asked in a sequential manner, very similar to how real-world problems are solved. Secondly, we have quantitative, where we conduct a survey with ordinal questions being prompted. Let's say how likely from 1 to 5, how important from 1 to 5. And the responses are fed into data mining models to construct so-called user profile containing all the attributes describing the user. This is quite interesting because we can experiment different data mining algorithms to see which one is more effective. Lastly, we have qualitative strategy where the user's past travel experiences are requested because we believe that past travel records can really assist in making the next travel plan. So now let's have a deeper look at the proposed framework. So here we compare two different scenarios. The first one, where we call it lazy agent, being that the user input something and the agent directly respond to it, say, oh, I can help you with that, no worries. But this is not ideal because essentially it's like question answering machine, back to ChatGPT. The second scenario is quite interesting, where you input a task and the agent will talk to you in an interactive manner. So here we depicted our full design framework and also with some example. So here, given a task, we can determine whether we wish to understand the task or understand the user with a given strategy. So here, for example, plan a trip to Kuala Lumpur, we can say we wish to understand the user with this quantitative strategy. Here is where interaction happens. This one, since it's quantitative, we use survey from 1 to 5. The user can answer like 10 questions. And based on this question responses, we can do data mining. And then we have a more transformed, detailed form of the task. And by looking at it, we can already say that this task is already better than the initial task in having more information. To prove that our proposed framework is very effective, we conducted two different experiments on this implemented Taurus assistant agent, which by the way is done by Python using Jupyter Notebook. First of all, we experimented the different data mining algorithms, and a random forest stands out to be a very effective method having the best performance. Secondly, we experimented with some qualitative assessment based on this task of plan a 5-day trip to Kuala Lumpur. So here, based on this task, we implement 4 different set of strategies. First of all, we compute the baseline and we see, wow, it's not really good. It has 20% confidence, which is very low, and it has to make 5 assumptions in order to solve the problem, which is a lot of uncertainty. So we identify the most effective approach being understand the user with quantitative and also understanding the task, which with this checklist method, which will provide the highest confidence of 90%, which is already a 70% increase from the initial task. Now, I would like to quickly run you through with a live demonstration. Here, we use Python Jupyter Notebook to create this interactive environment for user to interact with our Taurus Assistant agent. You can really execute line by line in a sequential manner. So welcome to Capi Voyage, which is my favorite animal, capybara, and also a travel. Your one-stop AI assistant agent for travel planning. So now let's run the code. And also here we define user input. You can enter anything, but here we just say plan a 5-day trip to Kuala Lumpur. Here we define the agent, which I will talk about this later. And now let's look at how our agent operates. First of all, evaluate the task, because that's essentially the first step. If the task is really, really good, meaning it has all the information, is a saturated version already, we don't really have to do any interaction. We can directly respond to it. But here, after we evaluate, we can see that the performance, or let's say the evaluation result, won't be very good, because plan the 5-day trip to Kuala Lumpur, even you give it to me, I don't know how to answer it. So here, entropy 3.16 is fairly low, confidence is only 20%, and the explanation is saying that no sufficient information is provided, meaning that we cannot solve this problem now. So now let's write the code. And yeah, if the request seems to have some missing information, and would you like to engage in like a few minutes survey or Q&A information gathering process? Since we already know it's quite bad, let's go yes. And here we have different strategies, as we have mentioned earlier. Let's choose this quantitative, and then it has to get some information from you. It asks you some question, and it's ordinal question, so you enter from 1 to 5. How important is luxury accommodation? Let's say 5. Yeah, there are 10 questions in total, and after you have responded, you basically gather your response and then run the data mining model. So here, let's look at this in more detail. The first one refers to budget level. In the first question, is it luxury accommodation important to you? And I say yes, 5, extremely important. It means that if you live in luxury hotel, you must have a lot of budget, right? Because that's very expensive. So basically, each of the questions can contribute to some of this user profile or user attributes. And it's quite accurate because our data mining model has an accuracy of 83 something percent. Thank you very much. And then we can even move on to the second stage where we wish to understand the task. You can say yes, you can say no, but here we just say yes. And here we conduct using checklist, where you basically answer a set of questions based on a qualitative input. So what's the expected duration? Let me just also answer based on my case. So after we have answered this question, you will basically complete the transformation process. And here we are evaluating again with the transformed task requirement. And we see that entropy is nearly doubled. The confidence 70% is quite good already, above the threshold, with a very good user profile and detailed task requirement. And here, if we examine this actual response, we can see that it's luxury hotel near KLCC, which is my task requirement. I also wish to go for this kind of a local cuisine. And essentially, it's really following what I have said in this information gathering process. So what exactly is going on? Let's have a deeper look. First of all, what about our data mining algorithm? Here, we basically created the synthetic data, being survey response, and also the corresponding user profile. We have 100 records. Here, we train our model with sklearn. This is the vanilla decision tree. Here, we conduct hyperparameter tuning to really increase the capability of this model to have a higher accuracy. We have sport vector machine, random forest, and also neural network. And we save this model in this Pico file here with their parameter and also the model. And these models are used in this interaction process, where of course we can directly respond, but we also wish to do some interaction. So this is what you see when running the code of an agent. And here we can see different strategies implemented. One thing that is very important is this quantitative, where here it load the random forest model because it has the highest accuracy, and then it predicts the user attributes. And also, lastly, we have task evaluation, where we basically implemented the entropy evaluation, confidence evaluation, and also assumption evaluation. Here, confidence evaluation, you can see it's very long because we are implementing this few-shot learning or in-context learning to assist the large language model in evaluating the confidence. But of course, large language model is not our focus, so we are not going to dive into it now. So that's all for this live demonstration. Thank you very much for watching.